Students, I so appreciate your focused diligence today. Looking forward to a fabulous report of your progress on this particular lesson. Right here, you really want to have a couple colors handy. We're going to go through 3 simple examples over the next about 7 minutes. Follow along carefully. Start and stop the video as needed to keep up. So today's lesson is about undercover right angles. There are right angles hidden in circles. That's why I have this little detective guy, undercover. And they are hidden where you have a tangent and a radius or a diameter. In last night's videos, we have this jingle. Mary had a little lamb. I'd like you to just fill out this blank first, and then we will sing together. I anticipate you singing while watching this video and shocking the daylights out of your substitute, folks. Okay, so you have filled in the blanks. If tangent to a radius, radius, radius. If tangent to a radius, right angle at the edge. Ready, folks? We're going to do this twice. I expect you to sing. Yes, sing, folks. Mary had a little lamb. Ready? Sing with me. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. Alrighty, folks, now that you're over that shock, you're going to sing and trace at the same time because you are just so talented. Let's sing and trace at the same time. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. So wherever there's a tangent to a radius, and I would also say a diameter, which would be the same thing, there's going to be a undercover right angle. And where there is an undercover right angle, you are going to have undercover right triangle, folks. We're going to do 3 examples together. Alrighty, folks. So we're going to solve for the unknown, but you're going to remember you can always draw in or move additional radii, which are spokes in the wheel. Also, when you see radii, I'd like you to mark all radii congruent. That's super important. Always trace all radii and realize you can add in more, and always mark all radii congruent. Once again, a radius is a spoke in a wheel, in the wheel. Always, wherever you see them, mark them congruent immediately. That I would add trace and mark congruent. Let's do 3 examples together. Alrighty, in circle O, that means O is the center. The length of the radius is 6 centimeters. So let's trace that. 6 centimeters, center to edge is 6 centimeters. A to B, which is this segment from here to here only, squiggle it, that's 2 centimeters. Our ambition is to find the length of A to C. A to C, which is right there. Your ambition is to find X there. So taking a look at what you have, let's trace and sing. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. So immediately you have a right angle there. Let's pull this triangle out. COA, right here. Let's see what we have so far. We have 6 centimeters here. Our unknown is A to C. Problem is that we're missing a side length, folks. We're missing A to O. Now, I'd like you to physically trace A to O here. Notice that's missing. I'd like you to bracket it. A all the way to O. Put a little question mark there. You have that too. Ready? This is what I mean by trace all radii. I'd like you to trace the radius A to O again. Now, trace the radius O to B. Do it again, A to O, O to B. Those are both radii, folks, which means I want you to mark it congruent. So if O to C is 6, O to B has to also be 6 centimeters. Which means the segment we really want right there, folks, add that up. Ooh, you just figured out that that whole thing is now going to be 8 centimeters. We're going to solve for X here. Have 2 sides, need third side. Third. Let's write that out. Let's circle plug chug, folks. Circle plug chug. Our one leg is our unknown. Plus our other leg is 6 equals our hypo, of course, is 8. I'm going to give you a 10-second lead, folks. I'd like you to do that math on your own. Simplify your radical. I'll give you a 10-second lead. Go. Keep your hands off those calculators, folks. For single-digit addition and subtraction. Come on, don't be messing with that. The opposite of squaring is square rooting, folks. The opposite of squaring is square rooting. So if you have x squared, we're going to square root. I'm going to factor here. I get 2 and 14. And 2 and 7. 2 comes out, 7 stays, so our x here is going to be 2 root 7. So watch out for Pythagorean theorem here, folks. Wherever there's a right angle, look for right triangles. And any of those right triangle tools are fair game. Let's try the next one. That's example 1. Example 2, you're going to be doing this kind of stuff where you have to find the measure of all the angles, The trick to this is watching out and physically tracing everything. So start by finding your right angles. And in this case, we have a tangent right here. And we have a radius or a diameter right here. Go ahead and sweep that whole diameter. Ready? And sing. If tangent to a radius, radius, radius. If tangent to a radius, right angle at the edge. Now in this diagram, it only seems to be asking for one thing, but you will never find just one item. Instead, you will find all possible angles. Let's take a close look to see what's going on for this one. Right here, that 104 is a central angle. So sweep it. And we know measure of a central angle to its arc the same. So we have 104 out here. Watch out for simple stuff like diameters. So let's trace our diameter here, which is all the way there, 180. Why don't you take a moment and find that arc while you're at it? I'll pause here. You do your own math. Should have gotten 76. That arc, and there's the center, again, measure of a central angle to its arc the same. Let's see what else we can do. Let's take a close look right here. I'd like you to physically trace, please, the radius here and the radius here. Physically trace those. All radii are congruent, so we have ourselves an isosceles triangle. Where you have 2 equal sides, sweep it. You have 2 equal angles. So we're going to do 180 minus 104. And divide by 2. You should be getting 38 for both of these. Alrighty, put 2 little dots right there. I'd like you to physically sweep. That gives us 180, which means this angle right here, from here to there, of course, is 180 minus 38. At 142. And we just keep finding everything we can and watch out for giant overlapping triangles. Ready? See this giant overlapping triangle? So in that triangle, let me make a miniature version here. We have a right angle right there. We have 38, and then we have this unknown angle, squiggle. So I think you could see to get that last one, if you minus the 90, it's simply going to be minus 90 minus 38. Of course, that's 52 degrees. All right, students, so watch out for things like diameters. Watch out for things like central angles. Watch out for the right angle. And keep track of isosceles triangles and giant triangles as well. Find all possible arcs and angles in those type of problems. We're going to do one more here. This is an easy one. This really helps if you have colors right now. Colors, get some colors out. This really makes it easy. We learned in last night's videos that the arms of a tan angle are congruent. So from vertex to point of tangency, color-coded. Vertex to point of tangency. Those arms are going to be congruent. Vertex to point of tangency, vertex to point of tangency. Those arms are going to be congruent. Vertex to point of tangency, vertex to point of tangency. Those arms are going to be congruent. Knowing that, I'd like you to find the perimeter of this shape. You're going to walk it all the way around, obviously. We need to find each and every segment. So just keep track of those congruents. Ready? Let's do the simple stuff. This 9.5, squiggle it. Is the same as that 9.5. Now the whole thing is 21.5. So to get that red, we're going to subtract the 9.5. And golly gee willikers, folks, you can manage this without a calculator. Let's write this longhand, folks. Yes, it's a decimal, but you're smart like that. I know you can do this. All right, so we figured out that this red is going to be 12. And let's walk it around. That arms of a tan, so the 12 is going to be over here as well. Okay, let's come over here. This green, that's going to be 18.5 minus 9.5 again. And you see we get 9. So this is 9, and of course the arms are 10, 10. Now, you want to physically walk all the way around and add it up. Ready? Squiggle with me. We have 21.5. Plus 18.5. Plus 9 plus 12, which is 21. Let's add that up. Make sure you bring down that decimal. 1, 2, 3, and 8 is 11. You should be getting 61 units is your perimeter. All right, continue on pages 4, 5, and 6. Check the board as you finish each page.